So for this question, we need to know how to differentiate. So let's just run through that very quickly. Differentiation. If you want to differentiate y equals to axn, where a and n are integers, you would have dy by dx is equal to you'd bring the n over, so you'd have n multiplied by a to the power of x n minus 1, because what you're doing here is you're bringing this n over here to multiply by like ax, and you're reducing the power by 1. This is the rule of differentiation you need to know. So you're bringing the power over to and then reducing the power by 1. So you'd have this. And also, when you're differentiating, any constants, after differentiation, they do not remain there. So now that we know the rules of differentiation, we can answer part B of the question. So it gives us this equation of a curve, and it's asking us to find the value of dy by dx when x is equal to 5. So the first step to do that is to find the value of dy by dx. So we write the equation y equals 3x squared minus 12x plus 7. And now we use these rules here to solve the problem, to get dy by dx. So dy by dx is equal to, what we do is we take this power and we multiply it by the 3. So that becomes a 6x, and then we reduce the power by 1. So now the 2 becomes a 1 because you reduce it. And for the second part, 12x is equal to saying 12x to the power of 1, right? Because x to the power of 1 is just x. So to differentiate this, we take the 1 multiplied by the 12, let's say 12, and then 12x, and then we reduce the power 1 by 1. When you reduce the power by 1, that just becomes 0. 12x to the power of 0. So now let's simplify this. Dy by dx is equal to 6x, because x to the power of 1 is just x, and minus 12, because anything to the power of 0 is 1, so x to the power of 0 is 1. So now it's saying, what's the value when x is equal to 5? So to do that, all we have to do is substitute in x equals to 5 into the equation. So that would give us 6, and then substituting x equals to 5 into the equation, minus 12. And that would be 30 minus 12, which is 18. So the answer is 18 here. Now for the second part of the question, it says find the coordinates of the point on the graph where the gradient is 0. So an important thing to know is that dy by dx is an alternate representation of the gradient function. So when it says the gradient is 0, it's basically saying find the point where dy by dx is equal to 0. So we write that down, dy by dx equals to 0 here. And now we can just solve. We know that dy by dx is 6x minus 12. We differentiated in the previous question. So it's 6x minus 12 equal to 0. Here, 6x minus 12 equal to 0. And then after solving it, you'll see that x is equal to 2. But that's not all, because it's asking for the coordinates of the point. The coordinates. So that means you also need the y value. So now that you have the x value as x equals to 2, you can take this value x equals to 2 and substitute it back into the original equation. That is y equals to 3x squared minus 12x plus 7. So if we do that, we know that the original function is 3x squared minus 12x plus 7. And we know that x is equal to 2. So now we just have to substitute it in. like this, and solve for y, this would give us 12 minus 24 plus 7. Therefore, y is equal to -5. So now we have x being equal to -2, we know that, and y is equal to -5. And that gives us our coordinates of 2, -5. So that's the answer for that one. 2, -5. So now we can work through the final part of this question, part C. So they've given us an equation in terms of y and the derivative. So it's asking us to find the value of p and q. So firstly, let me copy over the question. So they've given us this, and they've given its derivative to be 14x to the power of 6 plus 6x. So now what we should do is differentiate this original equation here. And to do that, we know our rules of differentiation. So we take the power of p, multiply it by 2, and then subtract 1 from the power of x. So that would give us 2p times x to the power of p minus 1. And then for the second part, it would be, you take the 2, multiply it by the q, and reduce the power by 1. So that would give us plus 2q times x to the power of 2 minus 1, which is just 1. So let's neaten things up. So dy by dx is equal to 2p times x to the power of p minus 1 plus 2q times x, since x to the power of 1 is just x. So now we should compare this derivative with this one, since they both are equivalent. But the first one that they've given us, this one is just in terms of x, whereas this one has unknown variables p and q. So therefore, in order to solve it, we must compare. So let's look at the first term. So we know that 2p times x to the power of p minus 1 is equal to 14 to the power of x minus 6, because they both are equivalent. So therefore, 2p is equal to 14, and p is equal to 7. And that would be our solution for p. Well, we can try substituting it in, and you'd see that when you have x to the power of p minus 1, that would be x to the power of 6, which is indeed the same. So it satisfies both conditions, 2p equals 14 and p minus 1 equals to 6. And for the second term, we have 2q times x is equal to 6x. So dividing x by both sides, we get 2q is equal to 6, and therefore q is equal to 3. And that would be our solution for q. And of course, what you should do in the exam is just plug these values, substitute them back into the original equation, these two over here, and then differentiate it and see if it's equal to 14x to the power of 6 plus 6x. And you'll find that it indeed does. So yeah, that was this video. I hope this video was helpful, and I will be uploading more. So if you have any further questions or any problems you'd like me to work through, please put them in the comments. And please like, share, and subscribe if this was helpful. Thank you.